Climate change is going to profoundly affect water management in the future in California.
We've already seen changes in our flood peaks, for example. So from the first part of the 20th century to the second, comparing the first and second parts of the 20th century, we've seen an increase in our peak day flows, our one-day flows, our three-day flows, our flood flows, essentially. And we expect to see that continuing into the 21st century as well. We've already seen a reduction in the seasonal variation in flows. We're beginning to see already more water coming in our rivers in the winter and less in the spring. And this has a real impact for flood control and droughts and being able to carry our water supply over into the subsequent seasons.
Climate change can refer to global warming, which is the concept of everything on average warming up. Not necessarily every day, but the long-term pattern changes that could lead to changes in snowpack or the jet stream. And we have a climate model that we can show you that'll depict global warming from a computer model perspective. The Geophysical Fluid Dynamics Laboratory is one of the agencies responsible for making a climate prediction model. What you see on the screen, on the sphere, is a temperature gauge and a key for what's going to happen in the future. But we're going to start in the past first of all. If the climate model does a good job of representing what we know already happened, then it has some credibility going into the future. So we're going to step this from the past, 1870, all the way up to present day and then into the future. And we're just modifying one thing, carbon dioxide. We start off back in the past in 1870 when the temperature is cooler than normal, cooler than it is now, so that's in blue. I'll put that into motion, and gradually over time as we raise the parts per million, that's the number at the end, we're going up to present day CO2 levels. Carbon dioxide levels nowadays are about 386 parts per million. As we come up through the Industrial Revolution, we're going through the 1950s and 60s into present day, we're burning a bit more fossil fuel. There's less controversy about the fact that things have warmed up as there is about the reason for the warming. But let me stop it near the present day. Present day carbon dioxide levels are at about 386 parts per million. That's where we are now. So you'll notice a uniform temperature pattern around the globe. On that key, the 0 point is sort of that yellowish to green chartreuse kind of color. So we're starting at present day, knowing the model showed us that it was cooler in the past. What we're going to do is double the amount of CO2 in the atmosphere, which is a realistic interpretation of what could happen, although the computer model doesn't take into account any changes we might make. But a doubling of CO2 is certainly a worthwhile measure of seeing what could happen in the future. The atmosphere will respond by warming up because the CO2 traps the heat that normally goes out to space. So we're going to increase that CO2. We're going to double it to 717 parts per million. That'll take about 100 years according to this computer model. Now what you'll see is that things really start to warm up more quickly over the land masses than the oceans. As we get up to that 717 mark, I'm going to put a stop on it, and we'll take a look at what's happened over North America. Things have warmed. We're now into the orange or red zone on this color depiction, so we're up several degrees Fahrenheit over California. That might not sound like much, but we've already seen an increase between 1 and 2 degrees Fahrenheit over most urban areas in California, and a few degree increase could really change our snowpack. If we're only going up even at this moderate level in California, by the middle of the century, there could be enough warming to reduce our snowpack by 25%. And a 5 degree Fahrenheit increase, by then we would lose 5 million acre-feet of water per year.
We've already seen about 1 to 2 degrees Fahrenheit increase in temperatures over the course of the 20th century in California and elsewhere. And what that means in the future is that, future projections go anywhere from, by the end of the 21st century, we could see anywhere from 1 to 6 degrees Celsius, and that translates to about 2 to 11 degrees Fahrenheit. And that could be even the lower end of that range. Even if we were to see, say, 3 or 4 degrees Fahrenheit increase in temperatures, we're going to see a reduction in the snowpack. And we think that by the middle of the next century, we could see, even on the slightly modest, the more conservative side of the temperature projections for the 21st century, we're going to see probably a quarter reduction in our snowpack. And that has huge impacts for our water supply. We depend upon this. A lot of people don't realize that the snowpack actually is sort of our third reservoir, if you will. We have actual dams and surface water reservoirs. We have groundwater, and both of these are very important to supplying our water supply. But we have the snowpack, which both of those depend upon. We depend upon the snowpack being there, and we depend upon it melting at a certain rate and at a certain time. And in the assumptions that were built into our water management system over the 20th century, climate change really brings those into question. And we need to think about how we're going to be able to operate those systems, both surface water and groundwater, in the future with this disappearing snowpack.
Now this depicts perhaps even a higher temperature change as we go past this point. Even though we're not going to double the CO2 or add any more CO2 to the system, watch what happens as we continue into the future. Triggering off the computer model into the future, things still warm up, and now the oceans warm. Things are slower to respond because the oceans have a slow response time. So we've gone another 100 years in the future, and now we're looking at potentially an 8 to 10 degree Fahrenheit increase in our temperatures. Now there is a range of possibilities. Some of the climate models say it'll be less of an increase, some a bit more. This one's about in the mid-range or perhaps a little warm. And we may do things differently in the future that this model hasn't accounted for. But nonetheless, even if we were to stop today adding CO2, it would be quite some time before the warming would be done.
One thing about climate change that's a positive is it actually pushes us to do things that we probably ought to be doing anyway. So things like water conservation, taking a look at our current water management system, seeing how we can reoperate it, optimize its operations, looking at opportunities for new water supply, whether it's surface storage or groundwater storage, looking at other water supplies such as desalination and recycled water. So these are things that we would probably do anyway to accommodate, or that we should do anyway, to address future uncertainties, whether they're climate change or they're population changes, they're changes in the economic sector, changes in land use. What we really need to do is have a portfolio approach, not sort of bank on just one water management strategy or another. Look at the whole range of water management strategies, and climate change really sends that message home.
California is already experiencing climate change, although it's tough to notice. Much of the warming happens at night, and it's an average trend over many years, not a day-to-day weather phenomenon. At the Golden Gate Bridge over the last century, the sea level has risen 7 inches, and the models indicate over the next century it could be another 7 inches to possibly as high as a 2-foot increase. That'll impact the delta.
Yeah, it really does seem like a small amount, 7 inches, and obviously we've endured 7 inches over the last century. You know, so what, another 7 inches, you know, our system should be able to, you know, we're talking about something like this. So, but it turns out that our delta levee system, for example, just one impact of such a sea level rise, is already on the brink. We already have a system of agricultural levees that historically weren't meant to protect urban areas. They weren't engineered in any real sense. They're very much just sort of piles of mud that have been built up over the years, and in addition to that, we have islands that are subsiding behind those levees. And so if you have islands that are subsiding and then you have sea level rise on the other side going up, you're just adding that much more pressure to our levee system. And really, climate change could be yet one more thing that pushes our levee system in the delta over the brink.
And if things continue to warm, we'll start to lose snowpack. That's because gradually, season after season, as it gets warmer, the snow level gets higher, perhaps each successive winter. That leaves us less to carry over into the reservoirs for the following spring, summer, and fall.
That's really going to be quite a challenge. We have built a water management system in California that really depended upon the snowpack being in a certain place, melting at a certain rate, as I said before, and being able to reoperate that system and to modify it to accommodate the changes that we're going to see in climate change. It's going to be probably the biggest challenge we have in water resources in the 21st century.
This is only one of the climate models, though. There is a range. Some are a little cooler, some are warmer. But no matter what the reason for the warming, we need to incorporate climate change into our water management policies. Adapting to climate change is going to be one of the most difficult challenges facing California in the future.